This video is on integration using residues. In today's video, we are going to solve the problem based on residue theorem. So in this video, we are going to evaluate integral 3z minus 4 by z into z minus 1 into dz, where c is the circle, that is mod z is equal to 2 using residue theorem. So here what is given? Integral f of z into dz. So clearly f of z is nothing but this is 3z minus 4 by, that is z into z minus 1. So in order to find the poles for this given function, we have to equate the denominator to 0. So if I equate the denominator to 0, that is z into z minus 1 is equal to 0. So this will be z is equal to 0, and this is if I equate z minus 1 to 0. So z is equal to 1 is one pole, and here z is equal to 0 is the another pole. So we got the two poles after equating the denominator to 0. And next one, see here. So what is the contour given? So here it is a circle. Mod z is equal to 2. So here, if mod z is equal to 2, then we can write this as mod z minus 0 is equal to 2. Clearly, this is also very simple. So here, as usual, so this is 0, this is 1, this is 2, this is minus 1, this is minus 2, this is I, and this is plus 2I, this is minus I, and this is minus 2I. So if I draw a circle like this, so this will be the circle with center 0. So this is center 0 and radius 2. So with 2 as radius, I am drawing a circle like this. Clear? And within the circle, z is equal to 0 is within the circle, and z is equal to 1 is also within the circle. So both the poles are within the circle, and we have to find the residues for these poles. So 1, 0 and 1 are within the circle, and therefore for finding the residue, see, residue of f of z at point z is equal to, z is equal to 0 is nothing but this is limit z tends to z naught, that is z minus z naught into f of z is the formula. So if z is equal to z naught, for 0 I am taking, see here, for the point 0, for z is equal to 0, the residue value will be, that is residue of f of z, this is residue of f of z at point z is equal to 0 is nothing but this is limit z tends to 0, this is z minus 0 into f of z. So what is f of z here? That is 3z minus 4 by z into, this is z minus 1. So if I cancel this z and substitute 0 in the rest of the function, so this will be 3 into 0 minus 4 by, this is 0 minus 4. So this value is nothing but minus 4 by minus 1, which is equal to 4. Therefore, the residue value of f of z at point z is equal to 0 is nothing but 4. So I got the value, the residue value of the function 0 at the pole value z is equal to 0. And the next pole value here is z is equal to 1. So at the pole value z is equal to 1, residue value will be the residue of f of z, residue of f of z at point z is equal to 1 is equal to, this is limit z tends to 1, that is z minus 1 into f of z. So this will be limit z tends to 1, z minus 1 into f of z. So what is f of z here? F of z is nothing but this is 3z minus 4 by z into, this is z minus 1. So if I cancel z minus 1 and substitute z is equal to 1 in the rest of the function, then this will be 3 into 1 minus 4 by 1. So which is equal to, this is 3 minus 4 by 1. So which is equal to minus 1. So this is the residue value of f of z at point z is equal to 1. So here is the residue value. The residue value is minus 1 at the pole value z is equal to 1. Therefore, we have to use residue theorem. So by residue theorem, see here, by residue theorem, so the statement states that by residue theorem, integral f of z dz is nothing but, integral f of z dz is nothing but, this is 2 pi I into the sum of the residues, sum of the residues at interior poles. So there are two interior poles here, 0 and 1. So now, therefore, integral f of z dz is equal to integral f of z dz is equal to 2 pi I into sum of the residues of the interior poles. The first interior pole is 0. At 0, the value here is 4. See, and the next 1, the value here is minus 1. So this will be 4 minus 1. So here this is 2 pi I into 3. So which is equal to, this is a 6 pi I. Therefore integral. So what is f of z value? F of z value is 3z minus 4 by z into z minus 1. This is 3z minus 4 by, this is z into z minus 1 into dz value is nothing but 6 pi I. So this is the value according to our residue theorem. See, let me explain you once again. Here we have to evaluate integral f of z dz, where C is a circle, mod z is equal to using residue theorem. So here I have taken f of z from this function, and after finding the poles by equating the denominator to 0, we got the two poles, z is equal to 0 and z is equal to 1. Here the contour is given as a circle with center 0 and radius 2, and therefore 0 and 1 are within the circle, and therefore we have to find the residue point, the residue value of at the pole z is equal to 0, and we got the value as 4, and the next at the pole z is equal to 1, so the residue value is minus 1. And by residue theorem, so we have to find out integral f of z dz value as 2 pi I into sum of the residues at the interior poles, that is 2 pi I into 4 minus 1, which is equal to 3, which is equal to 6 pi I. So this is how we have to solve. Thank you so much for watching and staying till the end. If you really like, go through the playlist once and check all the videos which are very very important. All those are previous questions, and it will be very helpful for your preparation. If you really like, please pass it on to your friends.